All right, let's start this from the beginning. In the beginning. Okay, so what we're looking at here is applying compounding rules that we've learned to practical problems. Okay, so real life, I should have taken that away, just ignore that. Real life applications where there is a percentage increase or decrease over time can be modeled using our formula that we've been using. So sometimes there's an increase, sometimes there's a decrease, and that's what we're going to have a look at. Just a few terms I want to run by you. Inflation. You may have heard of that before. It's a term that describes the increasing of costs that we have to buy. So you know how sometimes you go and apples cost $3 and then in a few months' time they cost $3.50? That's normally because of inflation. And it's measured by using the annual percentage change in the consumer price index, which is the CPI. If you ever watch the business part of the news, they talk about that. Population growth is measured using percentage change on previous years. So if you look at this, it shows you the growth in the world's population since the first fleet arrived in Australia. And you can see the change. It shows that there, and then there were lots of growth, okay, as far as people, population. So it was a positive percentage. You can see it went up. Appreciation is a measure of the increasing value of an investment over time. It's generally used for investments other than bank accounts. So it would be things that your rent has gone up. So therefore you get more money, therefore your investment goes up. Maybe the value of your house has gone up, okay? And that's called appreciation. Then real life applications, when there's a percentage decrease, can be used using this interest, but you actually take away your interest, okay? So it's exactly the same. You can see over here as a takeaway. What is depreciation? Depreciation is reducing the value of items like cars, computers, or machinery. For example, they always say a new car, as you drive out of the showroom, you lose 20% of its value of the first year and 15% of its value every year after that. We can use the compound interest formula with the negative interest rate to see what our value is. All right, so I'll just go back to that. Population decline. Sometimes there's a population decline because what was this? This was measles, and they showed how measles went down. People were getting measles, and then they gave the vaccination, and it went completely down. Okay, so there was a depreciation. All right, so if we apply the compound interest to growth or an increasing problem, let's look at one. A 3-liter bottle of milk is $3.30 at a supermarket in 2018. If the average rate of inflation is 2.1% per annum, which is per year, estimate how much that litre of bottle will cost in 5 years. Okay, so we go. So there's the question there. And we put in our formula. And we say, well, our principal is the milk is $3.30. We put our formula in 1 plus 2.1 over 100 because that is our percentage, and then it said 5 years, so we put it to the power of 5. Okay, and if you put that all into calculator, you'll get $3.66. So that is how in 5 years time that milk should cost you $3.66. Please remember 2 decimal places, round properly. So then what happens if they're saying how much will that 3 bottle of milk cost in 2030? Well, first of all, we've got to say, well, 2030 to 2010 is 10 years. So we know they're asking how much will that bottle cost in 10 years' time if the rate of inflation is 2.1, if it stays that, okay? So we put our formula in. We say $3.30, 1 plus 2.1 over 100 to the power of 10 because we're now doing 10 years, and we get $3.37. So in 10 years' time, it should be $3.37. Okay. If we now apply to a decreasing problem, so you've got a new car which is $29,990. If new cars depreciate at 15% per annum, estimate the value of the car in 6 years. So we put in our formula. We say our principal is at the value of the car. 1 minus, remember, we take it away, 15 over 100 because it was 15%, to the power of 6 for 6 years. And we get $11,310.71. So that's how much. That's quite a lot. Eh? You think about the car was $29,000, and here, that's how much it goes down. Anyway, I want you to give it a go for me.